Welcome to part 7 and maybe the last part, the trunnion build video series. In this part I'm gonna first make all the cover plates for these parts and finish up the wiring, make the quick connectors on this part so it's easier to get the trunnion on and off the table, wire technically. So let's make some parts. The first piece I'm gonna make is the cover for the C-axis servo. My approach on making these parts will be first drill the mounting holes, and then I can use screws to hold the part, and then with two contour passes I want to cut these parts out of this piece of 3mm aluminium plate. On the milling machine I mounted a big piece of wood where I can just place it on and use normal screws to hold the part. It's a quick and dirty method I used on my previous mill. I just gonna use mist coolant because flat coolant and wood will not be the right way, I guess. So just make it slowly, we'll be fine. So this is my quick and dirty setup to make these small plates. I use this thick layer of wood where I can just use screws to hold the material. So what I first now do is drill those holes, put screws in it, and then mill out the contour, and do that for each and every part I need to make. So that's the first cover finished. I will get it out, test fit it, and then make the rest of the parts off camera because it's quite boring, time-consuming process. All the covers now have been machined and I mount them all. Now it's time to get it all. I'm gonna dismantle everything and then just put it back together for the final time with all the right length bolts, right numbers, and run the cables through it. So get it prepared to get it finally mounted on the machine table. I now started to put back the parts together. Started with the main base and the side plate. I fully mounted the harmonic drive with all the bolts. This little steel plate is where the home switch of the B-axis will look at. So next parts I'm gonna mount is the sides with the belt, and so slowly work my way up. The B-axis drive has now been mounted. I decided to drill two small holes in the back of the lowest part, so if coolant will get in somewhere, it also has a way to get out and not secretly flood the whole compartment and drown the servo or the electric connections. Next up is the big part again. I need to tap the holes where the home sensors will get inside, and then I can mount it on the harmonic drive, put the shaft on, put this bearing plate on, and then from there work further. The home sensors are now inside. One is here for the C axis. In the fixture plate I need to mill a slot which is almost completely around, with one part still the same height as this one, so it will detect that high spot and will not detect the lower part of the slot. And for the B axis, it's this one. It will look at the small steel plate that's on the side plate. So now I can mount this part to the harmonic drive and then work on this side. The main part and the side bearing is now mounted. Now let's put back in the harmonic drive and the belt connection to the motor. The trunnion is now completely back together mechanically. Now it's time to run the electronics. I need to get these two cables running through here, down here to where the connectors are. These two home sensors need to go the same path. For inside this connection, I 3D printed this cable guide to get inside here. The idea is that the cables will be able to twist a little inside of that tube for the B-axis rotation, but it needs to be protected since they also need to run through the pulley, which is spinning at the Servo RPM. So let's run the cables, see if everything is gonna fit like I have imagined. The cables are now run through the trunnion. So for this servo, they start here, they go on an angle through the shaft, they will end up here, just going next to the shaft without hitting anything, over the pulley, down here, and then they come out here on this 3D printed tube, on this support, go down here, and they will end up here. Here I have to look for something else because the wires are now sticking out, so the cover will not fit. Maybe just gonna 3D print some kind of bracket so the wires can lay next to each other a little bit lower, so I can still use the original cover. Need to look at that. So now I'm gonna solder the connectors back on here, and also for this servo and for the home sensors, and make the cables that will go back to the CNC control panel, and then we can almost put it back on the machine. The connectors now have been soldered on, so this is how it looks like on the trunnion side, and the cable comes from the CNC mill. I use this black plastic tube to run the cables through, so it looks a little bit nicer. And then I have these connectors which I can just connect to the trunnion. This is how it looks like when the cables are connected. I just run the CNC to have it checked it all works. So now I'm gonna put the trunnion on the table, run the cable, run this tube, see if it's gonna be like how I have it in mind, and then I can start aligning some stuff. I placed the trunnion with the cables now in the machine. The tube is running like this on this side of the machine. I need to make a bracket that it will be held like this, because when the table moves all the way to the back, it just stops straight in front of the window. And if I keep it like this, I can use my full machine travel distance without the tube getting stuck on something. I made a small program to let the trunnion move a little. First go slower, a little faster, a little bit faster, and then go back at max speed. So mechanically and electronically it's finished now. The home sensor on the B axis is already working. For the C, I first need to mill the slot because now the sensor always detects some piece of steel, so the home function doesn't work. And then I can start align everything and try to make a real part. It's now time to work on the dovetail clamp I want to try to make myself. The way I design it right now, it consists of two parts. It's a riser plate and the actual clamp itself. I make this riser plate, gonna make it from aluminium, and then I can make different types of clamps that I can put on the riser plate. The riser plate I will make from aluminium 7075, and the dovetail clamp will be made of steel. It's a 4140 equivalent piece of material. So now I first want to CNC mill the riser plate, and for the dovetail clamp I first gonna make the outside diameter on the lathe, and then mill this slot in so I can mount it on the riser plate, and then with the 5th axis function I can index to drill this hole, drill the holes for the clamping mechanism, and cut the actual dovetail on the machine itself while it's already fixtured inside the machine. So first let's make this part, which is gonna be all 3D machining. And after that, let's make the dovetail clamp. The part has been roughed out and finished, this top part, side part. I cut it with mist coolant because the trunnion is not completely watertight yet, so I don't want to risk get water inside, coolant get inside. So now it's time to do the 3D milling around, which is going to take a while. This side of the part is now done. I need to back off the back side to get rid of the rest stock. I think I'm gonna do it on the lathe, just hold it like here, and then because I need to make sure that the back side is gonna be perpendicular to this side, and maybe once it's fit inside the 5th axis I'm gonna face off this part again to make sure it's as perpendicular as possible, parallel as possible. So let's see. First get it out, see if I can mount it in the lathe to do the other side. The riser plate have now been finished. The only thing I'm left to do is countersink these holes for the bolts that will hold the actual dovetail vise. So now I can mount it on the trunnion and see how it looks like. The riser plate is now mounted to the trunnion mounting table. So next step is to make the steel part, first on the lathe, then in the vise machine the back side so I can mount it on here, and then with the use of the induction function, the 5th axis, I want to drill the rest of the holes and cut the dovetail inside of the part. Let's see how that's gonna go, since that's gonna be the first real part machined on the trunnion. It's now time to work on the actual clamp. First thing I need to do is cut a piece of this material, turn it down to the right outsider diameter, and from there it will go into the mill and mill it when it's already mounted on the 5th axis. The lathe operation is finished, so the outside diameter is now the same as the model. I'm gonna hold it like this in the chuck and then mill this feature on it and drill the holes and put thread in it so I can just mount it on the riser plate. and then do the rest of the operations. I set the exact 0 point of the round stock with the use of a dial indicator, just mounted to the spindle, since I need to have the locating feature exactly centered before I gonna mount it on here. This op is now finished. It's now time to set up the trunnion, set all the work coordinate systems, mount this one on the riser, mount the riser on the table, make it run through on the Z-axis, and then see if I can machine this one with the use of 3+2 function of fusion. The dovetail clamp is now mounted on the trunnion. I set all the work coordinate systems on G55, so I don't have to touch it anymore before I ever remove the trunnion from the table, and then I will use G54 to mill parts on the vise. So now let's make the program to cut in the dovetail, drill the holes, saw the slot on it, see how it's gonna go on the first real part made on the trunnion. The zero point of the Z-axis is in the middle of the rotation here, so since I need to model up the work coordinate system inside of Fusion, what I do is I use the hammer, set this on 0, and then I can use this value to set the right distance from this point to where the coordinate system will be. I will show it in the campsite. So what I did is the stock is a piece of round bar with the length of the value that I get from the Z-axis reading, and put the coordinate system all the way down there on the stock material. So this is the rotation point of the trunnion of all axes, and then the part should be exactly located where it is in the machine. The first feature I want to machine are those two holes that need to make space for the socket heads. So I make this bore function, and what needs to happen is the trunnion needs to rotate 180 degrees and need to tilt 90 degrees to reach those holes, and then do the two bore functions. So let's see how that in real life looks like. Well, that vibrated brutally. Well, let's see how the other operation is gonna go. whole operation's now been finished. The dovetail is inside. I drilled this hole for the end of the slitting saw. I tried to use the slitting saw, but it burned on the first few, on the first pass. Seems the material is a little bit too hard for the slitting saw I want to use. So now I'm gonna try to cut it manually. And I need to tap these holes, and then I can try to cut the aluminium piece with the same dovetail, see how it's gonna turn out. But now I first need to get it off the trunnion to saw this piece. The dovetail fixture is now finished. The sawing didn't end up exactly as I wanted, but should be good enough. So first let's see how it goes, how it works, and maybe I will make a new one later. So now it's time to make a test piece with a dovetail to see how it's gonna hold up inside of this clamp. So I got a piece of square stock 50 by 50 millimeter already sawed, it's already in the vise. So I'm gonna cut a dovetail on it and see how this is gonna grip. I gutted the dovetail on the test part. As you can see, the clamp just slides on it, and if you tighten this bolt, it's just a rock solid connection. So now let's put this one back in here, center it again, and then just load the part, test part, and draw something which is gonna be fun to machine.